Hey everyone, it's good to be here with you today. Like I mentioned, my name is John Duffin, and I'm one of the simulation experts here at MLC CAD Systems, and I'm actually absolutely thrilled to be able to talk to you guys about simulation. Simulation absolutely blows my mind. Stuff that wasn't even possible to predict before is now becoming possible and saving companies money and time, and it is absolutely amazing. So as you guys can see and as you guys know, the title of this webinar is FEA, It's Not That Simple. Now, we're going to be focusing on simulation, specifically structural analysis with your FEA, and we're going to be looking at stuff that's, hey, maybe more on the simple side, but then get deeper into, hey, what may not be simple for what we're looking at. Now, hopefully this is going to be interesting for different kinds of levels of users, that people that, hey, I haven't really used simulation before, we'll look at some simple stuff compared to what would be a little more complex for you. And then towards the end, we're going to be talking more about some of these higher level simulation products that can simulate things like car crashes or very complex analysis like that. So we're going to go through the simple and then go through the more complex and then talk about, hey, what might be applicable for you guys. Now, what we have here is our classic bicycle. Amazing but relatively simple machine. You see it can be applied all different ways, from your mountain biking in the snow to your road racing or your just typical user consumer bike. Now, what I'm going to be talking about is a company that manufactures bicycles. Now, they ran into an issue that your crank on your pedal there was snapping for users after it had been out on the market for a few years. That they see lots of cases where people reporting that this was breaking. Now I'll show you a few pictures here of that. So it's your pedal crankshaft is breaking on these users after they've been out for a few years. And I'll get a more zoomed in look here. So you can see, hey, the crank that pedals it is causing problems. Now, obviously, this is a pretty big concern for the company. Not only is in a way affecting the safety of some of their users, but hey, warranty claims is increasing their cost, and then it's also affecting just the brand image of what you're doing. If people know your bikes to break, then that can affect this company's sales later on. So what we're going to do is we're going to look at what the process was for this company to evaluate different designs for crankshafts going forward so that they do not run into this problem. Now right here, I have an image of 3 different crankshafts that are being analyzed. And we're going to see, hey, with Solidworks Simulation, you can easily get these data to answer those questions. Hey, will this break? Hey, after so many cycles, is it going to break? So that this company, but then also people can apply it for all their other products, can avoid these kind of things in their designs. So right here we have 3 slightly different crankshaft designs. We see this design 1 up here. It's a relatively straight shaft with this slot cut out of it there in order to reduce weight. We have one that's maybe a little bit thicker towards the end, but pretty uniform, but a pretty smooth contours on that. And one that's quite a bit bigger, but it transitions more of that curve along the shaft. Now, the main design requirement for this is that this cycle has to last at least 7 million cycles. Now, I'm not talking about cycles as in bicycles. I'm talking about, hey, 7 million times of this being loaded and unloaded, which equates to about the usable life of this bike. So in order to do this, we're going to go through a little process. So very first, we're going to look at a simulation setup in Solidworks Simulation. And then we're going to talk about it after the end, talk a little bit about, hey, about this static study, what was simple and what may not be simple. Then we'll look at some of the results, see what this company can analyze about this crankshaft, and then we'll talk about Solidworks Simulation. Then after that, we'll talk about some of the higher level products. So very first, we're going to look at the setup for one of these crankshaft designs. So I'm going to go over into SolidWorks, and here I have that design 1 modeled up. So we can see, hey, we have our little section cut out there in order to reduce weight, but have a thicker on section here in order to hopefully get our strength is our goal. So I'm going to go ahead and start a new simulation study here. And I'm going to set it up, and I'll show you that for the setup process for a lot of these, especially simple parts, hey, that's a relatively simple thing. So very first, I go over here to my parts, and there's already materials applied, and that just took in the materials that are applied on your regular SolidWorks CAD environment and brought them in as a starting point. I look at how these components are interacted to each other. We're going to assume that these are bonded to each other, which is a fair assumption for the analysis that we're doing. We're going to add, hey, how is this fixed in space? Because if you apply load and there's no fix, it's going to fly off. So we're going to go ahead and add some hinge connections to where this bolts to your gear sprocket that drives your chain there. And we'll go ahead and say that center one is going to be fixed as well. So now we're going to go ahead and add our load. Now we're going to put the load onto our pedal, simulating the effects of the user. So we'll have here at the front of the pedal, we're going to have a total load of 300 pounds. Now this is a requirement that's saying, hey, if all the weight's over here, this would be what would be the expected loading for our design requirements. So I'll go ahead and confirm that. And then from here, I'm going to go ahead and just get some initial results out of here. So I'm going to mesh and run my part here. You'll see that it'll take a few seconds. It meshes the part, which breaks it down to a bunch of different equations that then it can solve, which is your finite elements. And then from there, it's going to solve our part, and we'll get, hey, at least our first level results here. Now we get some initial results. The deformation is exaggerated so that we can see it better, but our red portions are the ones that are of concern. So I look over here and see, okay, yeah, a little bit over 200 megapascals of load here is on that, and then we'll look later how that equates to the fatigue life or how many cycles that can handle. So going back to our PowerPoint here, I'm going to go ahead and we're going to talk about what is simple and what is not about this part. That question, just because we get results, does that mean your analysis is accurate? No, you need to understand more aspects about the theory, about your assumptions in order to do that. Yeah, we get lots of people that they'll come in, hey, I set up a study, I got some results, but this isn't matching in real life. It's like, hey, have you taken our training to understand, hey, more of the theory that goes on behind the scenes? Because, hey, you need mesh convergence in order to get that mesh to the right level. You look at some of your energy norm error plots to understand how your accurate results and understanding how fixtures affect results and things like that. So basically with here, hey, the setup, that's pretty simple, but for a new user, hey, understanding some of that theory may not be as simple. Now, as a side note here, generally for these simple studies, for these linear static studies, is what they're called, that we offer a 3-day course that's just solely focused on, hey, getting people up to speed on how to run simulations and understanding that theory so they can have confidence in their results. Now from here, we've set up our study. Now we're going to look at some of the results of our analysis. Now, on here, I'll go back to the simulation. And remember, our main goal was to analyze, hey, how is it going to fail as it needs to withstand 7 million cycles of this loading? Because not only is this loading happening once, but if it happens multiple times, it's going to decrease the life, which your classic example is a paper clip. Hey, you bend it once, it doesn't break, but you bend it back and forth lots of times, and it eventually breaks. So I'm going to go ahead and I'll do a fatigue study, saying, hey, if I do that loading from my static analysis, so many times is it going to survive? So I'll go ahead. I'm going to add an event, which is, hey, how many cycles am I going to do? I'm going to tell it, hey, I want that cycle to apply and then go back to just no load applied again. I'll type in that this is going to happen 7 million times. And then go ahead and confirm that. And as long as you have the right material data in there, then hey, that's all you need to do to analyze your fatigue life of what it is. So I'm going to go back to the PowerPoint because it compares this process for a few different designs here. And we look at this table for our design one. So as we saw, hey, our max stresses was in this corner of this bracket, and we found that the maximum cycle life is about 1.5 million cycles is what it can withstand before it breaks. Even though our max stress is below where our parts permanently deform, that is not meeting our design criteria. Now we look at our second design here, and we find that this is a lot better. That we've increased our weight slightly, so we went from about just under 400 to just over 400 grams of weight. But now our lower stress, that our design cycle is well over that 7 million that's required. Now we'll look at this last design, which is, hey, the bulkiest and the heaviest, but with how it's designed, it may not be intuitive, but it actually ends up having some higher stresses along these corners here, and that this is actually the weakest design of what it is, that, hey, you have higher stresses in your part, lower factor of safety, and therefore, hey, lower number of cycles that this will be able to withstand before breaking. Now, obviously for each part, you need to understand your setup and what's going to do, but you saw that was pretty simple setting up these parts. That you can get results like this, that you could have literally saved this company a lot of money, millions of dollars, depending on how widespread the designs go, and really with just a few days of training and a basic knowledge of simulation. So we see, hey, what the simple part is, hey, setting up your study, doing it there. Hey, what's a little more complicated is understanding the theory, understanding what's important, which is why we have trainings in order to help you guys succeed. Now with that, we're going to go back here and we're going to go to our next step of talking about some of the different packages with Solidworks Simulation, and after that we're going to talk about some of the higher analysis that's available for more complex analysis. So within Solidworks Simulation, there's your three main levels of licenses. So you have your standard, professional, and premium. Now the study that we set up is going to be your typical study that you're normally doing to answer questions of, hey, does my part break under normal loading? Where I'm saying, hey, if this permanently deforms, it fails, and things like that. So that's a very, very common study that people do, and that's going to be in your standard package. Now, your fatigue studies that we did, where we look about, hey, how does this hold up under multiple cycles of loads? Hey, that's also in your standard package. As you go into professional, you start answering some more complex questions that can happen. Hey, if you're taking in the effects of thermal loading, where you have heat transfer, you have that kind of study there. Frequency, where you're answering the question, hey, if this is attached to a motor, things there, is the vibration going to cause more? Is going to cause failure prematurely. You have buckling analysis. Hey, you have long cylinder components that can buckle. Is that going to cause failure? You also have tools for optimization to help kind of automate those designs. How can I change these dimensions to get the design goals that I want? So these are the main ones in professional with that. Premium is where you go into more of your non-linear studies, which as a base level is, okay, you have higher deformations, you're going past the yield point of your material, so it's permanently deforming. With that, you have dynamic studies, which you're taking in the effects of, hey, if I apply this a little slowly compared to, hey, if I hit it, and some things like that. Now we'll see as I go on to this higher level simulation how this corresponds well, this premium level with the Simulia products, which I'll talk about. But I want to give a brief overview. Hey, for a lot of people, this is where they're standing. They're just analyzing, hey, will this part break as I apply these loads? But hey, maybe I need to understand how it's attached to motors, or I have long slender components, or I want to automate my design process. Hey, you might need to go into professional what you're doing, and then depending on your parts, you might need to go into premium. So with that, I'm going to go ahead and switch gears here, no pun intended, to talk about Simulia. Now this is the next level up in simulation, which is an absolutely incredible tool for some more complex simulations. Now I'm going to show you some pictures and a video here of some examples of what can be done in Simulia. Now here is some analysis of a car crash. Now this is like the pinnacle of simulation of hey, you have very high deformation in your parts. You need to analyze, hey, is this person going to be safe in there? You see you have this deformation plot over here on the left, and even on the right is, hey, simulating the car crashes, cars going down the road. A very, very complex analysis in order to perform. So with that, hey, a lot of people aren't doing car crash simulations, but I'm going to show a few examples of some other types of examples where people go into this product. Now, really, the main reason people go into is they have studies that they're going past the yield point of the material, so the permanent deformation is an area of interest, and you have lots of deformation in your part is really the overall criteria of where you go into this higher level simulation. So some other examples here that people use our Simulia product, which is powered by Abacus, which is a very well-known simulation product there, is that we have blow molding over here on the left, which is analyzing the manufacturing process of creating these plastic bottles. Hey, maybe you're trying to optimize the wall thickness to use as little plastic as possible in this, or just making sure that it is molded correctly in that. Hey, you have high deformation, you're interested in the deformation after it's applied the loads there. Hey, that's a great application for that. Over here on the right, have a similar but different process of thermo molding with it. So you blow up this plastic with air, and then you put your mold into it, and then you do a vacuum to suck down your shape. Now you could be answering the questions, hey, is this going to break as I do this mold process? These molds are very expensive to make, so you could have saved a lot of money by simulating this beforehand before having to go make another big mold like this. But those are some examples. Hey, you have parts with high deformation that are interacting there is where you go to these higher level parts. Now, with that, depending on your need, this becomes more complex in your analysis of what you're doing. It's a little harder setup comparatively to what we've looked at so far. So I'm going to show you just a brief setup of a relatively simple part within Simulia. And I'm going to go ahead and I'll pull up a video because it takes a little bit longer to set up, so it skips through a few parts there, but I'll talk through what a typical setup is when you're in Simulia here. So what we have here is a bracket. So your main metal part is a bracket, and then you have this rubber bushing. So hey, you have lots of deformation in this bushing here, so we're going to be using a nonlinear solver in order to do it, and we're going to use Simulia in this case. Now we'll go ahead and play here, but the first thing you notice that to begin with, we are still in the Solidworks environment. Now in order to use Simulia, it has a automated connector, so hey, you just save it out saying, hey, I'm ready to bring it to Simulia in order to simulate my products. It maintains that link between products, and then you go ahead and launch the software in order to start your simulation. Now your overall workflow, very similar. You apply materials, you apply loads, you do what you need to there. So in this case, hey, we're applying our rubber and we're applying the aluminum as the material in this case. So this will go ahead and apply our material. What we're doing, just like before, we added mesh to our parts. So added some more specialty meshes of what we're doing, which goes back to the question is, hey, is my results accurate? So apply some meshes to our part here. And then right here, we're applying some of the loads like we've done before. And then also, hey, how are these parts interacting with each other? So very similar, just a slightly different interface from what you're doing. So we'll go ahead and watch that go through, applying, hey, what's the friction interaction between the bushing and between our main bracket here. Set up our fixtures. You set up your loads, and then you run it to get your initial results here. Now, the main thing I want to show too that people ask questions about is, hey, you have a different interface here. Does that mean I can change my designs? I have updates as easily as I would in Solidworks Simulation? And the short answer is absolutely. With that connector there, it does take a couple more clicks in order to connect it, but you don't have to reset your part up again there. So in this case, here in a second, we'll go back into the SolidWorks environment, and we change that bracket here to have a slightly smaller hole in order to meet our design requirements here. And we'll see, hey, we change the side, and we just go back to this connector and tell it, hey, we're ready to transfer these design changes over. And then you go back into the simulation environment and just, hey, say, I'm going to update my geometry, and you just tell it, hey, remesh and rerun, and you're good to go. So the main reason I wanted to show this example here is to say, hey, you have this higher level simulation as you have products that have high deformation, that you can get results and get amazing simulations, amazing data out of it. It is still linked to the SolidWorks world in order to update your designs, but it does become more complex in your setup of what you're doing, but it is absolutely a game changer for companies that need it. So now to go back, I'm going to talk a little bit about the licensing within Simulia. Now on this page, this is similar to our product matrix that we looked at for SolidWorks Simulation. And this is actually going to look pretty confusing here, but I'll kind of break it down in a relatively simple way. So basically, there are 4 levels of licensing within Simulia, and these first 3 are relatively the same capabilities of what you would be in SolidWorks Simulation, where roughly with a few minor differences of saying, hey, this one's your standard with your static studies that we talked about, and then you have more studies as you're looking at, hey, how does this act under different loading, and then you have that base nonlinear solver, which is for, hey, maybe more a couple of parts or not super high deformation in what you're doing. But the main difference is as you go to this last one, which is your structural mechanics engineer, to have very high deformation in what you're doing. Now, the question that's sometimes asked is, hey, if these first 3 have relatively the same overall capabilities as SolidWorks Simulation, why would I even go to that in the first place? One of the main things is that, hey, your Simulia is a cloud-based product. Now, you have some advantage of that where you don't need all the same heavy hardware in order to do it. But then the other difference is, hey, you have this cloud computing. So on some of your solves that take a long time, you say, hey, I don't need these high-end machines in order to do it. I can send this off to the cloud. They solve it for me. They can solve it a lot faster because they have amazing servers and capabilities there and get your results back. The other reason people go here is saying, hey, at some point, I know I'm going to be needing to use this higher level simulation. Let's get used to the interface that's available here in Simulia. where even though your products are less expensive, similar to your prices of your regular SolidWorks simulation on these, that you can get used to it, and then it's a easier transition going to your higher level simulation. And just to reiterate that in one more way, here's a graph that shows basically the different products and its level of simulation here. So go ahead and click. Very first, we talked about SolidWorks simulation was what we looked at the first part of this webinar with that bike crankshaft. Now you have your different products. Hey, you have simulation standard, simulation professional, simulation premium, increasing capabilities as you go up. So go ahead and click again. And now we have our SIM-ple products, which are these ones in blue. Now, like I mentioned, those first three main products is relatively the equivalent capabilities of what you would have in SolidWorks simulation, with the main difference is, hey, you can now do those cloud computing if you so desire, which you could also run it locally as well. You don't have to do the cloud computing with that. But then these products up here, these are the ones where, hey, you have very high deformation where you're doing car crashes, you're doing blow molding, you're doing thermofoil loading, or a lot of deformation in rubbers and things like that is where you can go into these higher level simulation. Now I'll go ahead and show one more that I haven't talked about yet. And this is going to be your actual Abacus software. So like I said, these SIM-ple products are powered by Abacus. It uses the same solver, same technology. But we also sell and support your actual Abacus products, which is, hey, your desktop, not your cloud installation. And the reason why it's slightly higher on this graph here is most of the capabilities have been transferred over into the SIM-ple product, but there are a few niche applications that are in the works but haven't yet. So generally, hey, we talk to people, what are you simulating? And then if for the few people that can't yet or that isn't implemented over, hey, we would recommend your typical desktop, but your SIM-ple is going to have overall be better and a lower learning curve there. So with that, that is the time and a little over, I believe, for the webinar. But hopefully this gave you just a brief glimpse into some of the simulation capabilities. Simulation is absolutely incredible. I just did a very fire hose approach today of looking at, hey, a base setup in SolidWorks simulation, and then looking, hey, here's some of the higher level products that you might need. And then as you get through some complex analysis, what's available? There's a solution here for everyone. And really what I hope you guys get from this webinar is that you're thinking, okay, what's the next step for me? Maybe right now you guys are just getting into simulation and what it's doing. So it's like, hey, we just need to get some simple products here, but we need training because we maybe understand a few of the clicks of how I can say out, but we need to understand the theory so I can know my results are accurate. Maybe you guys already been using SolidWorks simulation for a while and you have some applications where you could save a lot of money and reduce the cost by using some of this higher level simulation. Whatever it is, we're here to help. Whether if it's we can help with training can help you succeed, whether if it's helping investigating, hey, these high level products, what actually do I need? And then evaluating it there. So with that, I'm going to open up for questions, but I'll let Marcus take the lead on that. But I'll go ahead and turn the time back over to Marcus. But thank you guys so much for bearing with me and spending a little bit more time. But hopefully you guys got a glimpse into simulation, into how it's simple and how it can get more complex. And I look forward to talking to you guys in the future.